Welcome everybody to Greywater Action's 2016 webinar series. My name is Laura Allen. Today I am your moderator as well as your presenter. Before we get started, I have a couple of housekeeping items. If you want to ask a question or make a comment at any time throughout the webinar, just type it into the chat dialog box on your left, and I'll take several times to stop and answer questions throughout the webinar, and we'll have more time at the end as well. If you want to see a larger version of the slides, move your cursor over to the top right corner of the slide and click there, and that will enlarge the screen. There are going to be several of diagrams and things you'll probably want to get a closer look at, so remember that that's how you do it. But if you do want to make a comment, you're going to have to minimize that screen to get back to your chat dialog. So we're going to get started with today's topic, Understanding the California Plumbing Code for Graywater Installations. And as you notice in the slide, Graywater, we always spell Graywater with one word and the E spelling, which is how it's spelled almost everywhere in the world. But in the California Plumbing Code, it is spelled Graywater, two words with the A spelling. So both are correct. You can spell it any way you want, but I just wanted to clarify that. And before I get started in the presentation, I just want to share a little bit about my experience with the codes and how long I've been doing this. I started getting involved in Graywater codes in 2009 when California had its major plumbing code revision process that was stimulated by legislation that required that to happen. So I was a stakeholder in that process, along with many other Graywater educators and activists and installers. And since then, I've been active in the triennial code adoption process. So every 3 years, this happens again. And I've also worked with several cities in California to work on streamlining the permit process so they can have an easier mechanism for people to get permits in their cities. And more recently, I've become a member of IAPMO's Water Efficiency Standard. It's a technical committee that creates a standard that does work its way into other codes, as well as the Universal Plumbing Code, which influences California's plumbing code. And I'll talk a little bit more about that relationship in a couple of minutes. So we're going to get started. And so today we're going to talk about the code. And I'm going to talk about some kind of basic information about the code that's helpful to understand it. And then we're going to talk about who enforces the code. And it does depend on where you live, who these enforcing agencies are, and also who can get these permits. We'll talk about the key concerns with Graywater that are addressed in the code. There's some really common concerns from both human health as well as environmental health that are addressed throughout the code to make sure these systems are safe for everybody. Then we're going to look at the code. I say code at a glance because the code is quite long. It's 11 pages, single-spaced, small font, and there's just no way that I could go through the entire code with you in a reasonable amount of time. So I'm going to highlight some of the most important parts and some of the parts where people getting permits are going to need to interact with the code and do some calculations, but I'm not going to go through everything. And I do encourage you to read it over on your own many times. It takes time, but you'll get familiar with it as you go through it more. And you'll also get a sense there's common vocabulary and language that are used in building codes that at first, if you're not familiar with it, is a little bit harder to understand like what they're really meaning by it, but you'll get used to it as you get more experience. And then we're going to end the presentation with looking at getting a permit and the range of potential experiences. So as you're probably aware, it's not always easy to get a permit, though in some areas it is very easy, others it's not so bad, in other places it's extremely difficult. So look at the range, and then I'll conclude by making some recommendations of how a community can have a really easy permit process that maintains health and safety as well as incentivizes legal systems. So some basic information about the code. There's a lot of acronyms. So the California Plumbing Code is referred to as the CPC. It's created from IAPMO's Model Universal Plumbing Code, the UPC. The UPC is created by this organization called IAPMO, the International Association of Plumbing and Mechanical Officials, and they create the Universal Plumbing Code, which California adopts and then modifies it. HCD is the Department of Housing and Community Development, and they modify it every 3 years based on stakeholder input as well as their input. This California uses a triennial code adoption cycle, so every 3 years the code is revised and adopted, and there is an interim cycle where some small modifications are made. But in general, every 3 years is when the new code comes out. The Department of Housing and Community Development, or HCD, they are the entity that currently writes the code that covers graywater, and they propose this amended code to the Building Standards Commission, or BSC, and they adopt it and approve it. So as you're reading the Graywater code, you're going to see HCD and BSC. You'll see these acronyms, and that's what they stand for, and they're two different agencies in the state government. And I want to make a kind of emphasis that there really is a big need for input of graywater practitioners, because the people who are writing these codes, they are responsible for this broad range of codes covering not just graywater, but the whole plumbing system, as well as all of the built environment. And graywater practitioners have a really unique perspective because they experience how these regulations affect their job as installers. And so the more input there is from practitioners, the better we can get the codes. So they're easy to comply with, and that they make the most sense. So in California, graywater is found in the California Plumbing Code. It's in the California Code of Regulations, Title 24, Part 5. And just a brief history, in the past, like before 2009, it was in the appendix of the code. It moved around a few times. It was Appendix J, Appendix G, and the Department of Water Resources was the agency responsible for that code. And then in 2009, I mentioned in the beginning, there was legislation that kind of moved things around significantly. It took the graywater portion and gave it to the Department of Housing and Community Development, and they created what was called Chapter 16A, that code. It was called the Non-Potable Water Reuse Systems, and it was inserted into the 2007 California Plumbing Code. And so now, since that time, it's been just on this triennial code adoption cycle. So we had the 2013 version. It was now called Chapter 16, Alternative Water Sources for Non-Potable Applications. And the next code adoption cycle, which is happening really soon, the 2016, is going to be moving into to be called Chapter 15 with the same title. So currently, like right now today, we're using the Chapter 16 of the code, but by January of 2017, we're going to be using Chapter 15. And these codes are very similar. They're almost identical, not quite, but pretty similar. And so that's my next slide. And I'm going to take this moment to apologize. There's some kind of strange formatting that happened in transferring my presentation from my computer up to this webinar service, and it changed some of the color of the font from white to black, so it's hard to read. So I apologize for that. Hopefully you can read it well. So the upcoming 2016 code is going to be published July 1st. That's coming up pretty soon, and then it will go into effect January 1st, 2017. And the URL is up here, and if anyone has trouble reading that, I can send that to you in an email. Like I mentioned, it's a very, very similar code. There's just a few changes compared to the one we have today. And so something of note is, depending on where you live, your town or county may not actually be using the most current version. And so if you're getting permits or getting into this work, you want to find out what version of the CPC is adopted by your city or county, because not all areas are up to date. So you may find that your local jurisdiction is working off an older version, and so that's just something to note. And you also want to find out if there's any ordinances about graywater that have influenced how graywater is regulated in your area. Some communities have these really old, outdated ordinances that maybe were progressive at the time, or maybe they weren't, but they were written a long time ago, and they are still impacting how people can get these permits. And potentially your community has created a new ordinance to be more restrictive than the state code, but most likely they haven't. So it's always good to find out what's going on. And I just noted in here, if you can read the font, it's a little bit small, but the code kind of, if your community is using the current version, this is all in effect for you in getting graywater permits, unless your community has enacted a local ordinance through a public process. So they had to have a hearing. It says a city, county, or other local government may adopt, after a public hearing, an enactment of an ordinance or resolution, building standards that are more restrictive than the graywater building standards adopted in this code. So it's possible that that occurred in your area, but they would have to have gone through a public process. They couldn't have just decided on their own without telling anybody that they're going to be more restrictive than the code. And the last question is your dwelling covered by this code? So I'm going to bring your attention to this code adoption matrix, which is found in the beginning, the first chapter. It's like the page before the code starts. There are different dwellings and different types of buildings are regulated by different entities, and I find this very confusing and kind of convoluted. And so just so you know, if you're working in other buildings that aren't just a single family home, this code may not be fully adopted for your situation. So I just want to turn your attention to the circled HCD up on the top. It's HCD1 and HCD2. An HCD1 is covering dwellings like a house, condominiums, hotels, apartments, and there's more. HCD2 is covering permanent and accessory buildings in mobile home parks. So if you lived in a mobile home park or the building was in a mobile home park, the regulations would be slightly different for you. And if you look down on this chart, there's little X's where they have adopted the section. And so they have both adopted the chapter as amended and with amendments listed below. And then you get down to all these sections. There's like section 601.1, 601.2, et cetera, all the way down. And this is just a little portion of this chart. And you can see that HCD1 has got X's in almost every square, but HCD2 is starting to have a lot of blanks, which is meaning that they haven't actually adopted a bunch of the code. And so that is something to know as you're going to get a permit if you're working in a building that is not being covered by this code. It'll be a little more difficult. Not impossible, but it will be more difficult than just being able to use the code as it is. So who enforces the code? In the code, there are two terms that are used frequently: the authority having jurisdiction, or AHJ, and the enforcing agency. And who these agencies are is open to local interpretation and precedent. In general, it's always going to be the building department, because when you're putting in a graywater system, you're usually changing the plumbing of the building, and that's going to be triggering a plumbing type of permit. So the building department is almost always seen as an enforcing agency for graywater, though in some cases the county level environmental health department is also seen as the enforcing agency, especially if your site is not in a city limit. So if your site is in the county but not a city, most likely the environmental health department will be your enforcing agency, and probably also the county building department. And then sometimes the county public health department is also viewed as the enforcing agency in that community, sometimes zoning, sometimes grading. There's a lot of different departments that might be seen in that community as the enforcing agency. So you want to find out for sure who in your community and your site is going to be the enforcing agency, and it might be more than one department. And then who can get a permit? So graywater systems, like any construction project, have to comply with California contract law, which says if the job is costing over $500, the installer must be licensed. The code itself doesn't specify which license can install the system, because graywater bridges a lot of different disciplines and trades, and so it is definitely some plumbing work. So plumbing contractors, they can get permits for graywater systems. It's often plumbing work plus more additional work, so sometimes general contractors can also get a permit to do a graywater system if the system and the work that's happening around the system includes at least 3 trades. So maybe there's going to be cabinetry work to access the valve. There's going to be also irrigation or landscaping work. So then a general contractor could also get the permit. And then a landscape contractor, for an irrigation system, the work is more landscape contracting work than anything else, so there is a little bit of plumbing alteration. So landscape contractors can get permits to install graywater systems. And the last one is general engineering contractor, Class A. They also can get permits. So it could be any of these people or a combination of them depending on the job. And then also an owner-builder, the homeowner, they can pull a permit. Almost everywhere allows owner-builders to get their own permit, so you don't have to be licensed if you're building it in your own home for yourself. If anyone has questions, feel free to type them in at any time. And just something of note, this is not covered in the graywater section of the code at all, but you should be prepared to do upgrades to your plumbing if you are getting a permit. So if you have an existing home and your home is old and has plumbing, it might not be up to date. It might actually be in really bad shape. Lots of homes are. And so if you have an inspector coming to look at your graywater system and you're going to be altering your plumbing, you're going to be tapping in to put in your diverter valve, most likely they're going to want you to upgrade the rest of your plumbing to meet the current standards. They're not going to make you replumb your entire house, but anywhere you touch, usually up to the main sewer line, that's usually where they're going to ask you to fix it. Though, of course, I guess they maybe could ask a lot more than that of upgrades, but in most situations, they're only going to ask you to upgrade from where you're changing something until you get to the main sewer line. So be prepared for that, and it's usually a good thing to upgrade your plumbing because there's going to be a problem if it hasn't already occurred with the old plumbing that's really in need of fixing. So the code is addressing some key concerns. These are common concerns of regulators, and there's going to be, as you get more familiar with the code, you're going to see these protections coming in multiple ways. So there's a lot of safety factors to make sure that our graywater systems aren't causing harm to anybody. So the first one is the code is very protective of human health. Graywater is not potable. It could have germs in it. We don't want anyone to contact that water and then to ingest it. So there's a lot of ways that the water itself, as it's going through the system, is designed to not be exposing anyone to contact. So we're preventing human contact with the water. There is going to be contact during maintenance, but that's a time when people are understanding they're getting into the system. They're going to put gloves on. They're going to take precautions to make sure they're not getting this water back inside their body. And so, but in general, the system is designed where people are not contacting the water. The code is also designed to prevent pooling. Pooling of water, standing water, that is a place for human contact as well as a place for mosquitoes to grow. So there's multiple ways that the code prohibits pooling and also prevents it through some of its prescriptive requirements. It's designed to prevent vectors like mosquitoes. We don't want our graywater to breed mosquitoes. So there's multiple ways, again, to prevent that. Hazardous inputs, so the water is going into the landscape. The code prohibits putting hazardous inputs into that water, like home photo labs, which really aren't as common anymore, but there's a list of things that you're not allowed to put into that water because it's not safe for you to have future contact with it or for the environment. And then the last really big one, there's many, many places in the code that make sure that your graywater system is not going to cross-contaminate the potable supply. So if you have a graywater system where the water is being pumped and it's pressurized, if you design your system improperly, you could potentially pump that dirty, non-potable water back into the municipal supply, which could cause problems, health problems for your family and other people down the line. So there's many, many places that prohibits that, prevents that. If there are any places where two pipes, a non-potable pipe and a potable pipe, are going to be connected, you have to have separation of either an air gap or a device that is a reduced pressure principal device that is designed to only allow water to flow in one direction. So the graywater couldn't flow the wrong direction into the potable supply. So you'll see that throughout the code. And then there's the protection of the environment. Graywater contains nutrients, which are fine for your plants. That's fertilizer, but nutrients getting out into the environment, into the water in particular, is going to cause algae to grow, and that's a source of pollution. So the code's preventing runoff. It contains setbacks, so your graywater is not coming out too close to waterways, to drinking water wells. That's another health prevention. And it also prevents hazardous input. So there's that, making sure that you're not putting the wrong thing into the water. So you're going to see those kind of two big protections over and over in different ways throughout the code. And I want to clarify, so in the Graywater code, there is untreated graywater, which is used for irrigation, and there's treated graywater, which is used for non-potable indoor uses and could also be used for irrigation. And so there's minimum water quality requirements. If you're using untreated graywater for irrigation, there are no water treatment requirements as long as you're putting the water into the landscape, either subsurface, subsoil irrigation, or disposal field. So there's different mechanisms to put the water out into the landscape, but as long as it's going below ground, it's being covered preventing the contact and it's going for plants, you don't need to treat the water because what's in it is really just nutrients for your plants. You might filter the water to prevent clogging, but you're not actually treating the water. On the other side, there is on-site treated graywater systems, and that's a specific term used, and the requirements for treated graywater are different throughout the code. There's two ways to have the minimum water quality requirements in the code. The local public health authority having jurisdiction can create water quality requirements for that local area, or NSF 350 shall apply. So NSF 350 is a third-party certification of systems, and they have their own water quality requirements. I'll show a little bit more about that. And again, the treated graywater is going to be used for indoor or it could be outdoor irrigation, but it has more potential uses than the untreated. So NSF 350 it's a certification process for manufactured systems regarding the water quality, and the uses again are indoor like toilet flushing or surface or subsurface irrigation. There's certification for both residential and commercial systems, and what they're testing for is BOD, biological oxygen demand, TSS, the total suspended solids, turbidity, pH, and E. coli. It's actually testing for some water quality constituents in the water, and it has to prove that it's meeting their requirements for reduction of those measures. And then when it's certified, the water can be used for other applications than just irrigation. So getting back to basic requirements, and this is mostly for irrigation uses, though it could be for indoor, but the indoor has a kind of separate set. The basic requirements are each system is going to be designed with a diverter valve, so you have a way to redirect the water. That said, there are some of these manufactured systems don't use diverter valves, but they do have a mechanism to get the water back to the sewer if need be, so there is a little bit of flexibility, but the code does say that it has to have a diverter valve. You can't put poopy diapers or other similarly soiled garments into the water, as well as hazardous chemicals. That's not allowed. You can't have spray irrigation or ponding, pooling, or runoff. And your outlet has to have a 2-inch cover. This is preventing the contact. You have to have a maintenance manual, so that's going to stay with the system for the life of the system. Excuse me. And you can't connect your system to any potable water system without adequate protection. There are tiers of graywater systems. There is a washing machine tier, which, excuse me, is a system that doesn't alter your plumbing, and there's 12 guidelines. If you follow them, you don't need a permit. There's a tier of simple systems. This is under 250 gallons per day, and it's any fixture, and it does need a permit unless it's exempted by the enforcing agency. And then there's complex systems, and these are over 250 gallons a day, and they do need a permit. And for people who were following the Graywater Code in the past, you might remember there was a window back in 2009, early 2010, where there was a different tier excuse me, of single fixture. And these were systems that were just from one source, like one shower, and they did not need a permit either under the same requirements as the washing machine. But that tier has been removed, and it's been removed since 2010, so there's only a very short window. And there's a question about the 2-inch cover on the outlet. So the outlet is where the graywater is leaving the pipe or the tubing and coming out into the environment, so that's where it's irrigating. And there has to be a 2-inch cover over it. It's usually a valve box, some kind of way to cover it up. If it's in drip tubing, it might just be covered by 2 inches of mulch. So however the water's coming out, it needs to be covered by 2 inches of something. So groundwater protection is really important for many reasons, and there are different mechanisms of the code that do protect groundwater, making sure that the graywater doesn't enter groundwater without having at least 3 feet of soil. As the water is flowing through the soil purifies the water, it removes the nutrients, it filters it, and when it enters the groundwater, it will be a quality enough that it won't cause any problems to the groundwater. So The code says the Graywater cannot discharge into the groundwater with a minimum of 3 feet separation. And if there are places where there's seasonally high groundwater, then you can just divert the water back to the sewer or septic. So it doesn't mean that you can never use Graywater if you occasionally have high groundwater, but you can't actually use the system during those times. And if there's a questionable location, like you're not sure if you have high groundwater table, you can dig a 3-foot test hole to prove that there is not groundwater in that area. If you dig down 3 feet and water fills in your hole, then you should not be using Graywater in that area. But it's a really good requirement because you're having to prove that you're within a safe amount of distance. You're not having to actually prove where the groundwater table is, which some codes do have that requirement. And that's, if your groundwater is 100 feet down, it's really hard to prove that. But if all you have to do is prove it's not 3 feet away, then that's not so hard. You just dig a hole. So there's a lot of there's some different calculations that you're going to need to do in the code to prevent pooling and runoff, and that's prohibited in some areas. And then it's also kind of you'll see how this works. So basically, the code makes sure that once you figure out how much water you have, that you have an adequate distribution area, so you don't put too much Graywater into one location, because too much water into a location with poorly draining soils, you're going to get puddling up of water and potentially runoff. So here's some calculations using the code. The first thing you need to do, and the code is going to give you a mechanism to do this, is figure out how much Graywater is going to be generated from the system. Then you need to know what is the soil type. If your soil is sandy, the water is going to soak in much more quickly than if your soil is clay. And then the last thing is how large an infiltration area is required. So you can see in this image, this is a system that's under construction. The Graywater is coming out under this black and with a green lid. That's called an irrigation valve box, and that is the cover. So that's your 2-inch cover right there. And then the water flows into the bottom of this basin and flows around the bottom of the basin. So that wetted area is actually about 10 inches lower than the level of the ground, and it will be filled with wood chips. And so it's giving this large capacity where the water can flow and then soak down over time without pooling or running off. And the code is going to help you calculate how big to make that basin. So in the code, there are a couple of ways that it allows you to estimate the discharge. There's 3 ways. They say you can use, number 1, water use records. Number 2, calculations of local daily per person interior use. Or number 3, the code procedure. And almost every single jurisdiction is going to want you to use the code procedure, even though there are these 2 other ways. So you should be prepared to use that, even though it's the least accurate, because it's kind of it's just an estimate and has nothing to do with the actual patterns of the people in the house. And then note that you are going to need to be distributing your Graywater daily. You can't store it if it's untreated Graywater. So however much water there is, even if you have more water than you need, or you're going to have to get rid of the water at least once a day, unless it's treated Graywater, and that's a different situation. So here is the CPC calculations for discharge. This is the code method. Number 1, you need to know the number of occupants, and it's based entirely on bedrooms. It has nothing to do with how many people actually live in the house. The first bedroom is seen as the master bedroom, and that's 2 people, and every additional bedroom you add 1 more person. And then the way they estimate Graywater use is showers, baths, and wash stations are all clumped together at 25 gallons per day per person, and laundry is at 15 gallons per person per day. And then you multiply them all together, and that's going to be your estimated discharge. So we'll look at 2 examples. So number 1, how much laundry Graywater is produced from 2 people in a 3-bedroom house. The 2 people doesn't matter because a 3-bedroom house is seen as 4 occupants, 2 in the first bedroom and then 1 in each additional bedroom. So you're going to look at 4 occupants multiplied by the 15 gallons per day and get 60 gallons per day of Graywater. And that's the number you would use on your permit and in your design based for your permit. So the second example, number 2, how much Graywater from the shower of 1 person living in a 4-bedroom house. The one person, again, you just totally ignore that because the 4 bedrooms is what's important. If the house was sold, most likely one person wouldn't move in. It most likely would be more people. So the code is asking you to base it on how big the house is. 4 bedrooms, that's 5 occupants times 25 gallons per day, and that would be 125 gallons per day. And you can imagine in reality, one person probably doesn't make 125 gallons per day every single day in their shower. And so as a designer, you're going to also need to calculate how much water they're really producing, because you need to know that for your plants. How many plants can you irrigate? So as you're getting into the code, there's kind of these dueling pieces of information. You want to design your system based on the reality, what's actually happening in the home, and that's going to guide you for your plants. And then you need to comply with the code and the permit requirements, and that's based on these theoretical numbers. You have to kind of hold both of those ways of thinking and designing the system, because you need to comply with both. So the words in yellow, how large a basin do you need to soak up the estimated gray water? That's really what you're trying to figure out. How the code speaks about it, it says the required area of subsurface irrigation fields, subsoil irrigation fields, and mulch basins. So that's the section of the code that you are going to be looking in. And there is a table in the code, and that helps you determine the maximum absorption capacity of the soils. So the table 1602.10 is on the right, a little piece of it. You need to know the soil type. And as you look at that table, you can see the soil types are they don't really match up with common soil types in other situations. So there is kind of that challenge of the code isn't quite aligned with what are actual common soil types. The soil types in this table in the code are coarse sand or gravel, fine sand, sandy loam, sandy clay, clay with considerable sand or gravel, and clay with small amounts of sand or gravel. So you're going to have to figure out which type of soil you have based on those types, and then you can do a calculation. Kind of a challenge with the code and with people getting permits are some jurisdictions allow the installer to do a site soil test, which is really easy to do. Some want a more professional certified soil test, which is extremely expensive. And the code does say for soils not listed in that table, you need to do a percolation test or some other method that's acceptable to the authority having jurisdiction. But those official tests are quite expensive. And if you have soils where the water won't soak down, the Graywater system can't be built. You shouldn't be putting a lot of water in that landscape anyway. So you have to have the right type of soil environment that can absorb the water you're putting out. So once you know the type of soil, you can see the full part of that chart. It's called Design of 6 Typical Soils. You are going to calculate the square footage that you need. So you have your gallons per day, you have your soil type, and you are going to use a coefficient. It's the second column. So in that example, in that little blue box, let's say you had 100 gallons per day in fine sand. You would go along the fine sand column over to that number 4, 4.0, and you would do 100 gallons divided by 4, and you would get 25 square feet. So you would at least need 25 square feet to distribute that water. It doesn't have to be in one area. It might be distributed over maybe 10 trees if you're watering 10 trees, but you're going to need to show on your permit that you have at least that many square footage to absorb the water. So determining soil type, the best way is using a field test. That picture is showing someone doing a soil ribbon test, and this is something that landscapers can do. They're very familiar with. We teach our installers in our 5-day class how to do this. It's really not hard. It's a basic test, and it can give you the soil type very accurately. If your area doesn't accept the installer to do their own field test, you can do a laboratory test. That picture is showing the results. It's just giving you the soil type. And these type of tests are very low cost. They're $30. You do have to mail it to the lab and get the results back in I think it's about 2 weeks, maybe 10 days. So that's also a very reasonable way if your authority having jurisdiction doesn't accept your own field test. Getting into a professional field test, like a professional percolation test or some other type of soil test, it will be very expensive. So we want to avoid the need for that. And the code doesn't require that. It doesn't say you have to, but some local areas, that's what they feel comfortable with. So we want to make sure we can have tests that are accurate as well as affordable. So going back to that minimum irrigation field, this picture is showing one tree being irrigated by one outlet. So that's going to be a portion of that, and all of the different plants being irrigated, you're going to add up all those irrigation fields all together, and that's going to meet your minimum square footage. In general, systems are designed so they're designed kind of just naturally designed to irrigate the plants based on the actual amount of water that's flowing through. And in general, it's not hard at all to meet that minimum irrigation field. Usually you're a couple times more than you need to be, which is good to have a safety factor built in. And in general, it's not hard to meet that. But you do need to show on your permit that you are meeting the minimum. So here's a picture of a warm climate. This is in Joshua Tree in the desert. And so these basins are much bigger. There's only 3 plants being irrigated because of the plant water requirements, how much each plant needs. It needs more water, but there's nice big basins to soak up all the water from the shower that's directing that water out. In the next picture, this is in San Francisco. So the same amount of water can water a lot more plants. And you can see they're little basins. The soil is very quickly draining in this area, and each basin is going to be irrigating different plants. So they're not planted yet. It's a construction picture. So in the code, there are setbacks showing where different parts of your system, how far away they have to be from certain things. For example, building structures. Your surge tank, if you have one, has a certain setback away from building. Your irrigation area where you're actually putting the water, this is often a mulch basin, has to be set back a certain distance from buildings and property lines and water supply wells, things like that. And so when you do your design, when you draw it up and when you install it, you need to make sure you're meeting those setbacks. You can be farther than that, but you can't be closer than that. And I want to turn your attention to some of the superscripts, just so you can see that in the chart there's a little bit more information you need to know. Looking at the property line adjoining private property, says 5 feet. There's a red arrow pointing to the superscript 8. And if you go down to the bottom where there's that other red arrow, it says that distance shall be permitted to be reduced to 1.5 feet for drip irrigation and mulch basin irrigation systems. So if you're using drip irrigation or having a mulch basin, you can actually be within 1.5 feet of your property. So I'm going to talk about getting permits, like kind of what to expect. The best case scenario is your community has done a little bit of work and said, actually, we don't need a permit for these really low-risk systems. These simple systems, there's no pumps, there's no filters, there's no tanks. It's a very low-risk situation. And there's guidelines, and they've laid them out, and they say that if you fit the situation, you don't actually need a permit. The example of that is Santa Barbara County. They have exempted simple systems that don't have storage or pumps from any permit requirements. The systems all still have to comply with the code, but they don't actually need to be inspected or have a fee paid. So that's the best case scenario. A good scenario is your community has what's called a standard plan. So it's the building department and whoever is the enforcing agency has sat down and agreed on what is going to be required and actually written it up and drawn it up to give to people wanting to get permits so they can see exactly what they have to do. So there's standard plans for you to look at. You only have to get one permit, and the installer can conduct the soil tests on site, or you can use a lab. Examples of this happening is Oakland and Los Angeles, and there are more places too. Getting into the not so good situation, your community requires 2 permits or more, so maybe a plumbing permit plus an environmental health permit plus maybe can be a range of others, and the cost of getting multiple permits just takes the cost gets really expensive, and if you're doing the work yourself, it can double or triple the cost of the installation, which is really not an acceptable cost ratio. And then the worst case scenario, your community requires double or triple permits, and they want to see the on-site soil test done from a soil engineer or a certified percolation test. So that's going to add thousands of dollars on top of the additional cost of your system. So we want to be in our the best and the good scenarios. We want everywhere in California to be there. So when you're getting your permit, some things you will probably give to the agency: a specification sheet, and this is a sheet that contains all of the basic info. So what fixtures are you tapping into, how many people, how many bedrooms, what's the estimated gallons per day, soil type, kind of just all the basic info, showing the setbacks that you're meeting them, showing what equipment you're going to use. Is it going to be a gravity flow system? Is it pumped? Really just giving all of those details. And here's an example made by a company in Southern California, Second Generation Water, for one of their projects. Some areas have this as a standard plan. So in the city of Los Angeles, you will just get their standard plan and fill it out. So everything that would go on another city's specification sheet, Los Angeles has a standard plan. So it's the same stuff, like what fixtures, how big is the house, how much gray water, what's the soil type, all of that. It's just in the standard plan. So it's really easy. You just fill it out. Then you're going to give a site plan. And this is a computer-drawn site plan using AutoCAD. You don't have to use AutoCAD, but some people do already know how and then makes really nice drawings. So professionals usually provide computer-generated various programs, but some kind of computer-drawn site plan. And it's very clear, easy to read. It contains all of the setback information, shows where the pipes are going to go. It has all the basic info on it. This one was made by Lee Gerard, an installer in Southern California. Here's a hand-drawn site plan. So it's showing the same stuff, the setbacks, the dimensions of the irrigation area, showing that you're meeting those minimum requirements. It doesn't have to be to scale, but it does need to show the property, the footprint of the property line, the house, showing that you're meeting all of the setback requirements. And this was the permit in Oakland. Here's on the standard plan from the City of Los Angeles. They're showing an example of what it looks like. And it's computer drawn, but they don't have to be. They can definitely be hand drawn if you are neat. Here's one that is actually having little photographs of the components just drawn in, so you can do that too. There's variation, but with the site plan, you're really wanting to show the inspector or the plan checker what you're actually doing. So they can look at your drawing and know where the water's going, what materials are you using, what parts are you using, and that you're complying with the setback requirement. So here's showing the water part of it, where the water's going. Here's a hand-drawn example. Again, it doesn't. You might make a little legend so you can show where the outlets are, the different fittings that you're using. And here's another hand-drawn example. You can mix, you can do a hand-drawn, you can scan it, you can add things with your computer. You just really want to make it clear and containing all the pertinent information. So then in some areas, with a simple Graywater system, all you need to provide is the specification sheet and a plot plan. Other places want more detail, and so some communities want an irrigation field detail. That's just showing a little more details about where the water is going. Here's the standard plan from City of Los Angeles, what they want to see. They want to see how are you putting the water into the landscape, and that's a simple mulch basin system. Your community might want to see what's called a riser diagram, and that's showing the plumbing. It's usually done with symbols. So you're showing where you're tapping into the plumbing. So the existing plumbing, they want to see the fixtures, their P-traps, their vents, where you're going to put your diversion in, and your backflow prevention, your backwater valve, which is preventing sewer from backing up into your graywater system. So you're going to show where your diverter valve is, where your backwater valve is, and how you're going out into the landscape. You'll show basic things like clean out, the slope of your pipe. It's a pretty basic drawing. It can be computer drawn or it can be hand drawn. Here's a couple of examples. So here's a hand-drawn one. This is showing the plumbing details, showing where the water is coming from, the pipes, where you're going to tap into it, and where it's going. And here's another riser diagram for a pump system. Whatever system you're building, you're going to show those plumbing components. And then some jurisdictions are going to want to see more details about the actual parts you're going to use, and not all, but some. So if your inspector is wanting to see what's called cut sheets are information about the products that you're using. So here's an example using the flow splitter. You can get these from on the internet. You can get them, usually the manufacturer will have a PDF that you can download about any product, or it will just be on the web page of where you would purchase it. So it's showing the material, the size, basic info about it. So here's one about the flow splitter. Here's one about the backwater valve that prevents sewage from flowing. If there's a clog down the line, it prevents it from backing up and then potentially getting into your graywater system. Here's one for a diverter valve. And then some areas have other requirements. This is a kind of, in my opinion, silly requirement from the City of Los Angeles. They want all the pipe to be labeled, even if it's ABS pipe, which is usually used for sewage. It's going to be below ground. They want it all labeled graywater. For many areas only require pressurized pipe to be labeled because pressurized pipe is going to be the same size and material as something that might contain potable water, so there could easily be a mix-up. So it's very important that you label all of the piping that couldn't be mistaken for potable. But sewer pipe, usually no one would think of tapping into that to use somewhere else. But anyway, you might have to label all of your piping no matter what material you're using. So you can print stickers. There's different ways to do it. But here's all of the pipe being labeled, caution, non-potable graywater, do not drink. And your clean out. Here's just some pictures from a permitted project in Oakland. The valve, everything is labeled, everything's properly plumbed. You're just going to follow standard plumbing practices in terms of what fittings to use and when you need a clean out and when you need strapping, what slope. It's all very standard plumbing. It's not anything graywater specific. Coming outside, if you're using, we often use plastic pipe in graywater. If you're coming outside, it will need to be painted and to prevent it from being sun damaged. So that's kind of a right before the system was permitted. And then before, so you build your whole system and then you have the inspection. And so some inspectors allow you to bury the straight runs of pipe. And here in this picture, you can see the joints are exposed. And this is the best case scenario because the inspector wants to see where the water's going and what fittings you're using, making sure all of that is good. But they also, many of them understand that if you leave straight runs of pipe unburied in the sun for a long time, it can warp. So you would ideally ask if you can bury straight runs of pipe. But some of them say no, and you have to just kind of strategically hold down the pipe before the inspection. Otherwise, your system can get out of alignment. So there's a question about the City of Los Angeles requiring permit for simple systems, and most places do. So these are simple systems, but you have altered your plumbing, so that's where it triggers the permit. Most places you have it's a one-time inspection, so you get the permit. Depending on your area, you might have to get it approved through the plan checker, and then there'll be an inspection after you have installed it. But there can be variation. That in Los Angeles, it is a one-time inspection. I'm going to end with just some recommendations. And this is to make it easier for people to comply with the code. The code there's a lot of flexibility in what is required, and that's up to local interpretation. And so the best situation for everybody is that graywater installers and homeowners can easily comply with the code to make sure our systems are safe and healthy for us and the environment, and it's not too expensive to do that. So the first thing is if local jurisdictions can exempt the simple low-risk systems from a permit, like what Santa Barbara County has done, that removes a big barrier because those systems are really just such a low-risk situation that to require a permit of several $100s is a big deterrent for many people. And the second thing is to create those standard plans. They're very helpful. Just the lack of clarity is a big deterrent for people too, and the lack of, you talk to one person and they tell you want this, and then you go the next day and it's somebody else and they want a completely different set of requirements. It's a big problem for installers. So we need to make sure all of our cities and counties have standard plans for both the gravity flow systems without the tanks and the pumps, as well as the pump system. And the last thing is just getting one permit. When you get those double and triple permits, it is pretty cost prohibited and time as well for most situations. So we want to get our local jurisdictions to talk to each other and agree on which is going to be the enforcing agency, and the other ones can waive their involvement. So those are the recommendations. And so I'm going to stop there for questions, and I see there's a couple of them. So it says, you stated the code for Santa Barbara County. Do you know if the city of Santa Barbara has the same condition? I believe it's just in the county right now, and I also think that they're working to improve the situation all over the county, but I don't believe the city of Santa Barbara is under that situation, but you could ask them. And there's another question, if the pump is only used for makeup water rather than the Graywater connection to the irrigation, can it be considered a simple system? Yeah, and the simple definition in the code is kind of funny because it's not the colloquial definition of simple, it's just a gallons per day. So in the code, a simple system is any system under 250 gallons per day. So that it could be a simple system. It's not actually a simple in terms of like not complicated situation when you do have a potable water connection that does add complexities to your system. But it would technically be a simple system. So there's a question about water savings. That is a great question. So how do you track water savings with the Graywater system? And there are different ways to do it. If you have an existing irrigation system and you're going to be replacing some of your plants, so right today they're being watered with fresh water on the irrigation system, and tomorrow when you finish your Graywater system, they will now be watered with Graywater. The easiest way is to replace an entire zone and then just shut off that zone, and then you'll know exactly how much water you are saving, because if it's a 3-zone system and you turn off one zone, you're now saving a third of that water. If you don't have an irrigation system and you are currently watering the plants with potable water, then you can estimate how much water you're currently watering them and then replace that with Graywater. So then you'll get an estimate that way. You can also check your water bills. That is another way. There are more things that go into our water bill. We don't get a bill for the outside and a bill for the inside, so it can be hard to know exactly how much you're saving if there's other changes in the home, like change in occupancy, change in types of fixtures, change in types of washing machines, all these other things that can affect your water consumption. So if you are looking to check water savings from Graywater, you want to be aware of all these other implications of like things going on in the home. Is there a new baby? Is there a new housemate? Did someone leave the home? There's all these other factors. And then there are ways to actually track the water in the more sophisticated systems where they are measuring the Graywater going through the system. So then you can get an actual how many gallons of Graywater did you use in the landscape. And that's going to be with the more sophisticated Graywater system. Okay, so are there any other questions? I think I got all of them. Oh, okay, another question. What about moving? That's a great question, and that's something that the code tries to make sure that the Graywater system built for the home is going to work for people in the future. So there's different ways, kind of different safety factors where that is going to happen. So if you get a permit, your system is going to be built based on the size of your house, not how many people you and your family are, but the potential maximum size of the home. Excuse me. So that's one safety factor. You also have the diverter valve, so you can turn off the system. And you don't have to, there's no requirements that you have to remove the system or even shut it off. You are required to pass on the operation and maintenance manual to the new owner. So you're required to have one for your system. It should include basic info like your site plan, like where the things are, how the system works, when you should turn it off. Like, for example, if you're going to scrub out your bathtub with some kind of really toxic cleaner, you need to turn off your system so you don't damage your plant. Or if it's raining a whole lot and there's puddles in your yard, you want to turn off your system so your gray water doesn't pool up. So there's going to be that kind of information in your manual, and that has to go to the new owner. So in general, new owners, it could be a selling point to sell your home, and the new owner might be excited about it and really want to learn. Or if they aren't, then you can just turn off the system and let them know about it, and they may not choose to use it if they don't want to. There's another question about, do you know of any specific requirements for multifamily residential applications? So with that, with a multifamily residential, you are most likely going to need to have an engineer design the system. It will be a more, definitely more considerations. There's going to be a lot more water. There's a lot more potential exposure. So there's going to be more safety factors that need to be built into the system to make sure that it's going to work well for a long time. One of the, most likely it'll be a filtered system, so there's going to need to be some more frequent maintenance. It could potentially be an indoor system. There's a whole other, it's just going to most likely be a lot more complicated of a gray water system because you're going to have more water. You'll want to spread it out farther or potentially use it indoors. And so you might have someone on site trained to maintain the system, or there could be a contract with the installer to come back and maintain it. But there are examples of that in California, so it's definitely possible. It just, there's a lot more to consider than for a single family home. And there's one more question about regulating. I think this is related to the, if you move. There is no, so there is the requirement that you pass on that manual, but nobody who, the person who gave you the Graywater permit is never going to come back to check that you passed it on to the next person. So that's just, it is a requirement, but it's not going to be, there's not going to be an inspection after the new person has moved into the home to check and see if they have the manual or not. So if are there any last questions? We're almost to the end of the time. I think I got all the questions. So thank you everybody for joining. This was the last webinar in our series. We will be having another one, and I'm going to actually be sending a little quick survey to everybody to get your input on topics that you would like to learn about more or more in depth if it's a topic that we've already covered. So be looking for that. Thank you all and have a good rest of your day.